Hey everybody, we're here today talking about continuous compounding. So we'll start with our good old formula, right? So we can think about it as a function at the amount that we have at the end of a particular amount of time in years is going to be a function of, well, our principal, whatever we start with, think about it like as the initial value, right? So whatever we start with, and then over time at an interest rate that's going to grow or decrease or whatever we're looking for, right? So there we go. Let's take a look at an example. So for the first one, you take $6,000 and you invest it at a company that guarantees a 12.7% return over 3 years. How much profit is that? Okay, so we want to start by figuring out how much is going to be there if we take $6,000 and invest it. We have to make this into a decimal, so 0.127, a decimal percent, times 3. Okay, and we can plug this value into the calculator and see what we get. So 6,000 e to the 0.127 times 3. Hit enter, and we get $8,782, and let's just say 49 cents. So if we subtract off, the $6,000 that we started with, we have $2,782.49 profit. Okay, not bad for 3 years. Okay. Example number 2. Okay, a house with a 30-year fixed rate mortgage at 3.6% ultimately costs $736,169.89. So we have lots of things, right? Here's our time, here's our percent R, and this is our value of A, right? We don't know our principal, we don't know how much the house was to begin with. So we'll start with 736,169.89 equals our principal times e to the 0.036. Again, be careful with that, times 30. Okay, and then honestly, what we can do is we could divide both sides by this whole amount, right? So that our principal is equal to 736,169.89 divided by e to the 0.036 times 30. Okay, and now we can plug this into the calculator. So we have 736,169.89 divided by, I'm going to use some parentheses just in case, e to the 0.036 times 30. Oops, be careful. In my parentheses, and go ahead and hit enter, and we can see that P is, well, let's call it 250,000. Okay, so yeah, it's very lucrative business to be in a bank. Somebody starts off with a house that costs $250,000, and over 30 years, you've ended up paying almost triple. You paid $486,000, right? Basically to borrow that money. Okay. Now, what rate would you need on an investment if you wanted to triple your money in 15 years? Okay. So in this problem, it might seem like we don't have enough information, right? We don't even know how much we're going to invest, P, right? We don't know what the rate is. So we don't know R, but we do know T. So it seems like we only know one thing, right? But what we know is that we want it to triple. So what is triple? What is 3 times P? Well, it's 3P. Okay. So go ahead and solving for R now, we could divide both sides by P to get 3 equals e to the 15R. Okay, and then we need to go ahead and take the natural log of both sides because we have base e here. So we take the log base e, that's natural log. Okay, so the natural log of 3 equals 15R. Okay, after we use the inverse property and cancel. And the last thing we'll do is go ahead and divide by 15. So the natural log of 3 divided by 15 is what our percent is. Okay, so we can come over here and take the natural log of 3 and divide that by 15 and see what we get. And so R is approximately 0.0732, right? So that's 7.32%. Okay, over 15 years if we want it to triple. All right, so go ahead and try that out. Hope and work on those practice problems. Good luck.